This is the third of 3 videos that answers the question, what method should I use when it comes to solving angles and sides of triangles? And the process I went through right now is I asked myself first, do I have a right triangle? If I did, I used right triangle trig ratios, otherwise known as SOHCAHTOA. When I didn't have a right triangle, then I looked at, did I have an angle on the side opposite the angle? If that was the case, then I was using the law of sines, which worked out for angle, angle, side, angle, and side, side, angle triangles. When question number 1 is no and question number 2 is no, then it pretty much leaves us with this, the law of cosines. And as you see, I'm going to be able to use this for both side angle side and side side triangles. Well, I happen to have a side here that's 18.11. I happen to have a side here that's 12.37. And I have an angle in between it, which is 69.62 degrees, or side, angle, side. So if I'm going to use the law of cosines, which is c squared equals a squared plus b squared minus 2ab cosine of c, then what I need to do, because I do not know what c is here, is I will have to plug in a. And it honestly doesn't matter which is your a and which is your b, because in the end, you're still going to take 18.11 and you're going to square it. You're going to add that to 12.37. You're going to square that. You're going to subtract 2 times 18.11 times 12.37. You'll multiply that by the cosine of the angle you were given, 69.62 degrees. And the beauty of this is you can literally type that into the calculator, which I have done in advance, and come up with an answer of 324.9609 approximately. The problem is you didn't actually find c, you found c squared. And since all lengths are positive, when we take the square root of this answer, it makes sense that we should expect it to be approximately 18.03 units. And so I have just found out that this side is 18.03 units and have successfully used the law of cosines. For my next problem, I would like to solve a side, side, side triangle. So what I've essentially done is I'm going to use the exact same triangle I had before. So again, this is 18.11. This is 12.37, but because I have just learned that this is 18.03, I'm going to go ahead and fill that in. And I would like to say, let's solve for angle B here. The problem is I don't want you to get hung up on that being B, this being C, and this being A. See, the law of cosines works when you have only one angle. And if you're going to solve for this angle, you might as well treat this as your C angle, and you might as well treat this as your C side. So when I start writing in my formula, c squared equals a squared plus b squared minus 2ab cosine of c, I'm going to get 12.37 as my c, and I'm putting that in apostrophes. Don't forget that that has to be squared. Now, which one is A and which one is B? I mean, this was originally A, but that doesn't mean it has to be A. It's not going to make that big of a difference. So just put 18.11 in for one of those and square it. Put 18.03 in for either the second one and square it, because it's not going to make a difference. You're going to square one, you're going to square the other, you're going to add them together. So which one comes first doesn't matter. And then even here it doesn't matter, because you're still going to multiply 18.11 together with 18.03. The only thing you're going to be left with is cosine of c at the end attached to this number. So I'm taking my calculator as we speak, and I'm typing in 12.37 squared, and I've come up with, let's see, here it is, 153.0169. I've got 18.11 squaring right now. I've got this to be 327.9721. I'm taking 18.03 squaring it. I've got 325.0809. I am going to take 2 times 18.11 times 18.03, hit enter. I have 653.0466 cosine of C. And since I want to solve for cosine of C, I'm going to need to get that all by itself. Except this is being multiplied to it, and these aren't. So I think the first thing that's going to make the most sense, let's emphasize this in red, is let's get rid of, where's my pen? There he goes. Minus 327.9721. We'll subtract that from both sides. 327.9721. I'm also going to subtract 325.0809 on this side. So negative 325.0809. So if I kind of work all this out, I'm typing in 153.0169. I'm subtracting 327.9721. I'm subtracting 325.0809. I hit the calculator, and it says that I'm getting negative 500.0361. And that's going to equal negative 653.0466 cosine of C. The reason I had to do that first is now I have to take a different approach when it comes to getting cosine of C by itself, because I need to divide this by negative 653.0466. Or before I subtracted, now I divide. So I got negative 6, let's try it again, negative 653.0466 being divided on both sides. So if I take my calculator and divide negative 500.0361 and divide that by negative 653.0466, I hit enter, and it's telling me, again, I'm trying to find my pen, I'm getting a number of 0.7657, and that equals the cosine of C. You have to remember that when you stick in C into a cosine function, you get a ratio out. And specifically, this is the ratio. And since it's cosine, it's saying that for every 0.7657 I go to the right, diagonally I will go 1. Now, we don't have to go into this great detail, but I want you to understand this is a ratio, that the cosine inverse of 0.7657 happens to equal 40.03 degrees. And that's how you use the law of cosines to solve a side-side-side triangle. So recap. Ask yourself, here's my triangle. Do I have a right triangle? If I do, great. SOHCAHTOA is the way to go. If not, do I have an angle and a side opposite that angle? If I have that, then go ahead and use the law of sines. If you don't have any of those situations, you're down to the law of cosines. But even then, you can solve your triangles. And that concludes how to go about solving angles and sides of triangles.